The product of two consecutive even or odd natural numbers is equal to 1 less in the square of the natural number between the two numbers. Now, before discussing this pattern, let's discuss one important thing that we'll have to use here. Let's say you have an integer a. It can be a positive integer, it can be a negative integer. And you have another integer b. Again, it can be positive and it can be negative integer. Okay, whenever you have any such product where you have to multiply a plus b with a minus b. Okay, so a plus b multiplied with a minus b, this is equal to a squared minus b squared. Okay, and let me show you the proof of it, because it's very important to understand the proof. Let's suppose that we take a plus b as x. Okay, let's take this as x. Let's assume that this is x. So we are assuming that a plus b is equal to x. Okay, so now we have x multiplied with a minus b. Okay, now this x multiplied with a minus b can be written as x times a, that is x multiplied with a minus x multiplied with b. What's this? This is distributivity of multiplication or subtraction, right? This is a property. Now this x is what? This x multiplied with a can be written as a multiplied with x. This is commutative property of multiplication. And same thing here, this can be written as b multiplied with x. This is commutative property of multiplication. Now this is a multiplied with, let's now put this original value of x, that is a plus b. So this is a plus b minus b, and let's put the original value of x, that is a plus b. From here you get a multiplied with a plus a multiplied with b, the distributive property of multiplication or addition, then minus b multiplied with a, and then, or let's say, and then plus b multiplied with b, distributive property of multiplication or addition. From here you get a squared and plus a multiplied with b. Now this is b multiplied with a plus b squared, and if you solve it you get a squared plus a, we can write it as a multiplied with b, minus this is ba minus b squared. We have opened the bracket. Now this is a squared plus ab, we can write this as ba as ab, right? Because commutative property of multiplication is a times b is equal to b times a, and this is minus b squared. From here you get, this is plus ab, this is minus ab, this gets cancelled, and you get a squared minus b squared, right? So why is it important? Let's discuss it here. Remember this, a plus b multiplied with a minus b, where a and b can be positive, can be negative, doesn't matter. The important thing is this plus sign and this minus sign. So this will be equal to a squared minus b squared. So if we have to solve for this pattern, it says if you take two consecutive even or consecutive odd natural numbers, let's take 2 and the next consecutive even number will be 4, right? Similarly, let's take 6 and 8, and let's take 10 and 12. Okay, this is for even number. Now this is 2, and we have to multiply it. Now this is 2. Can we write this 2 as 3 minus 1, right? And multiplied with, can we write this 4 as 3 plus 1, right? We can write it. Now this is what? A minus b times a plus b. It's the same thing that we have discussed here. Whether it is a plus b times a minus b or a minus b times a plus b, it doesn't matter because it's a commutative property of multiplication. You can exchange their position. So from here you get 3 squared minus 1 squared, and it is what? 3 squared minus 1 squared is what? It is 3 squared minus 1 only, because 1 squared is 1. Okay, so what's this 3? 3 is the natural number that comes between 2 and 4, and that is what this pattern is saying. The product of two consecutive even, ignore this odd one, we'll discuss odd also. So consecutive even, that is 2 and 4, is equal to 1 less in the square of the natural number between the two numbers. So which number lies between 2 and 4? 3. So this is 3 squared and minus 1, 1 less than the square of the natural number that lies between 2 and 4. Same thing here. Can we write this 6 as 7 minus 1? Yes. And can we write this 8 as 7 plus 1? Yes, we can. And this becomes 7 squared minus 1 squared, that is 7 minus 1. Now, sorry, 7 squared minus 1. Now, which number lies between 6 and 8? That is 7. Okay, so again this pattern shows that 7 squared minus 1 means that 1 less in the square of the natural number between the two numbers. And same thing we can do for this one. This can be written as 11 minus 1, and this can be written as 11 plus 1, 12, and from here you get 11 squared minus 1. Okay, now let's take a few odd numbers. So let's begin with 3 and 5, then 7 and 9, and then 11 and 13. Okay, we have to multiply these consecutive odd numbers. Can we write this 3 as 4 minus 1 and 5 as 4 plus 1, right? So from here again you have a minus b times a plus b, right? So this becomes 4 squared minus 1 squared, and you get 4 squared minus 1. So now ignore this even one and concentrate on odd one. So it says that the product of two consecutive odd natural numbers is equal to 1 less in the square of the natural number between the two numbers. Which number lies between 3 and 5? That is 4. So 1 less in the square of 4. Same thing here. This can be written as 8 minus 1 times 8 plus 1, and this becomes 8 squared minus 1. This is 12 minus 1 times 12 plus 1, and this becomes 12 squared minus 1.